All right, welcome back. What happens when a tongue twister champion breaks the law? He gets a really tough sentence. Okay, so we are doing tangents and normals. All right, tangents, hopefully we're familiar with. Normals is what we'll kind of talk about, and we're going to find the equations for them. That's what we're doing today. If we're drawing the tangent, just as a quick little refresher, if I want to draw the tangent at x equals -1 for this function, I will go up to -1. I will find where it meets the function, and I will draw a line that touches it once and once only. That is the tangent. Okay, now the normal, write this down, is the perpendicular line to the tangent. Okay, and it also needs to go through the same point that the tangent does. So essentially, if I was to draw it, it's this. I need to draw a line that goes through the same point that's perpendicular to my tangent. So if that's the normal, that's the tangent. Okay. Hopefully that makes a little bit of sense. The reason that we often need to know the normal and the tangent is because they will essentially they're not the opposite, but they negate each other in a certain way. So when you apply this in, I guess, the real world kind of physics, if one thing's pulling another way, you'll want to pull it the other way to kind of counteract its effects. That's why tangent, you'll need to know the normal. Okay, that's the idea. Now, I'm going to try my best here. I wrote this a while back, but I'm going to see if I can remember what I actually meant by leaving in these gaps. Now, this whole lesson is about finding the equations of tangents and normals. Okay, now, as we saw before, they are straight lines. So I need you to think, if we're talking about straight lines, one formula should be coming to mind. Thanks, puppy. That's not the one. It's this one. Okay, I don't know if you guys heard that. My dog's just going nuts. Y minus y1 equals to m bracket x minus x1. And we call this the point gradient. And this is where groundbreaking stuff. That means we need a point and we need a gradient. Okay, now the point, that should be easy enough to find. The gradient is actually found by the derivative. Okay, remember we talked about the gradient of a tangent being kind of your f dash x. This is where we start putting all of that together now. Okay, it's going to feel very, very methodical. And so the better that you can do your setting out, or the better notes that you write, the more it will kind of make sense. Now, just a little note on notation. Derivatives, they're often written interchangeably. I can say f dash x, I can say y dash. And this is the one that you haven't seen before, dy dx. All of these things mean differentiation. So I'm going to use them interchangeably. They all mean the same thing. A quick explanation for your dy dx. Whenever we see that, it means that we're differentiating y. We're differentiating y with respect to x. Or another way to think of it is it's the difference of y over the difference of x, which in other words is the rise over run, which is the gradient, which is kind of like our tangent. So all of this hopefully is starting to sink in. I'm pretty sure I've got one question. Find the equation of the tangent and normal of this equation at the point x equals to 2. Okay, so I want you to let's break it down. Every word matters. Equation of tangent and normal. Okay, this is equation of straight lines. We need to be using y minus y1 equals to m bracket x minus x1, which means I need a point. Okay, so far I've got half a point. I've got the x, I need to find the y, and I also need to find the gradient, which I'm going to do by finding y dash. Okay, can you see how a very short question, there's a lot of components involved? We're going to break it down and try to work on it together. Okay, I'm going to try and find the tangent first, because I think the tangent is generally the starting point. That's the one we're familiar with. So first things first, let's find the point. So I'll say at x equals to 2. How do I find y? Sometimes it's given to you, sometimes it's not. I actually have an equation for y. So I'm going to just use that. 2 times x squared plus 5 times 2, because I have an x value. So that's going to become 8 plus 10, 18. So that means our point is now x value of 2, y value of 18. So I'm almost there. I just now need a gradient. The way that I do my gradient is dy dx. Okay, so if I use my dy dx, that becomes the differentiation of this. Hopefully you're familiar. 2x squared will turn into 4x because the 2 will come down to the front. 2 times 2 is 4. And then that 5x will just become a 5. So there's your dy dx. Now to find the gradient of the tangent, and here's what I'll do. I know I'm writing gradient of the tangent. I like to write this, m, and then a little t. Okay, that there means my gradient of tangent. Gradient of tangent. Okay, I'm just going to write it just for this one example. But when I say the gradient of the tangent, what I really mean is mt equals to 4 times 2 plus 5. Now, why am I subbing in that 2? Hopefully it's clear that I don't want any tangent. I want the tangent at this particular point at 218. So I'm using the x value there. And that tells me my particular gradient at that particular point. It's going to be 8 plus 5, which is 13. Okay, that's my gradient. Now, while I'm here, I might as well find my gradient of my normal, which I hope you remember perpendicular lines means that m1 times m2 equals to -1. And so from here, I'll have -1 on 13. That'll be my gradient of my normal, okay? So there's the gradient of the normal. So to find tangent, which is what I said I'll do before, I'm going to go y minus y1. And again, it's going to be this point here. So y minus y1 equals to m, and the gradient of the tangent is 13. X minus x1, which is going to be 2. So in this particular case, for the x minus 2. And so for this one, looks like it'll be easier for me to leave it in gradient intercept form. 13x minus 26 plus 18. And I'm going to leave that as y equals to 13x. And then what's minus 26 plus 18? I think it's going to be minus 8. There's your gradient of the tangent. And the other one, they also asked us to find the equation of the normal as well. So it's still going to be a straight line. So it's still going to be y minus y1 equals to m bracket x minus x1. The only difference is it's still going to be y minus 18. The only difference is now we use the gradient of your normal. So in this case here, I'm using -1 on 13. X take away x1, which is still going to be the same point, 218. And so from here, if I'm seeing that kind of gross fraction, my guess is it's going to be easier to leave it in general form. So I'm going to times everything through by 13. 13y take away, what is 18 times 13? Somebody help me out. 18 times 13. That's 234 equals 2. And I'm left with -1 here, minus bracket x minus 2. So I just times everything through by 13. And then I've got, I'm going to plus the, let's do minus x plus 2. So you can kind of see it's a little bit gross, but I'm going to push that all over. It's going to be x plus 13y, and then it's going to be minus 236 because I minus the 2 over to the other side as well, equals to 0. And that there is the equation of my normal. A lot to take in, kind of messy example. Hopefully that makes a little bit of sense. Note my working out. I think it's helpful to have a good, strong, structured set of working out. Okay, hope that helps. I'll catch you guys later. Alrighty, bye-bye.